So the topics which we will be discussing in today's presentation are fraction as part over whole, simplification of fractions, improper fractions and their mixed numbers, and how to make the denominators same. And once the denominators are same, then how to use that to compare and order the fractions. Fractions as part over whole. If you search on Google, you will find out that fraction is basically a part of something. So this means that fraction is not the whole value. It's only part of that whole value. And this is exactly how we write the fractions. Part upon whole. In terms of fractions, this part we call as a numerator and the whole is called the denominator. Let's take an example now. I have a pizza in front of me which is cut into 4 equal parts and I decide to eat one part. What is the fraction of the pizza that is left? So the direct data for the number of slices of the pizza that are left is not given to us. Quickly do the math. Out of 4 parts, I eat 1 part. How many parts are left? Yes, 3 parts are left. And how do I write down the fraction? Fraction is written as part upon whole. Part will be the number of pizza slices that are left and whole will be the total number of pizza slices. So my answer will be 3 upon 4, where 3 is the numerator and 4 is our denominator. A very important concept in maths is of simplification. As previously discussed in the presentation of ratios, in fractions as well, simplification means to divide the numerator and denominator by a common table. To find out this common table, keep your divisibility rules in your mind at all times. Simplification helps us to turn the bigger number of the fraction into smaller ones for easy understanding. Let's discuss 2 examples over here. Our first question is 12 upon 18. By looking at these numbers, I can see that both the numbers are ending with an even number. So they will be divided by 2 times table. 12 divided by 2 will give us the answer 6 and 18 divided by 2 will give us the answer of 9. 6 upon 9 is our new fraction. But we're not done here yet. We can see that 6 and 9 again come in the same table. That table is 3. Divide both the numerator and the denominator by 3 and our final answer will be 2 upon 3. As previously discussed, you are going to simplify your numbers till the time they can no longer be divided by the same table. Question 2. 25 upon 65. Now using the divisibility rule for 5 times table, I can see that both my numbers are ending with 5 and that is why they will be divided by 5 times table. 25 divided by 5, answer is 5 and 65 divided by 5 will give us the answer of 13. 5 upon 13 is our simplified fraction. You must have noticed that every time we discuss the chapter of fractions, 2 very important terms always come up. A proper fraction and an improper fraction. What are proper and improper fractions? Proper fraction is when the numerator is smaller than the denominator. An improper fraction is when the numerator is bigger than the denominator. Let's understand this with an example. I have a pizza in front of me which is cut into 4 equal parts and I decide to eat 3 of those parts. So my fraction for the pizza which I have eaten will be 3 upon 4. Notice how the numerator is smaller than the denominator. So this is a proper fraction. Now if I decide to eat 5 parts of the pizza, yes, that means I eat one whole pizza and I eat one more part from the other pizza. Now this fraction of the pizza slices which I have eaten is 5 upon 4. See how the numerator has now become bigger than the denominator. This is now an improper fraction. Mixed numbers and improper fractions. Improper fractions, as previously discussed, are where the numerator is bigger than the denominator. In such a case, because the format is not proper, so we often required to change them into mixed numbers. Mixed numbers is where there is a whole number along with a proper fraction. Using the previous example, I ate 5 upon 4 of the pizza. This means that I will eat one whole pizza which is cut into 4 parts. So all the 4 parts of this pizza. In addition to this, I will eat 1 part of the second pizza. So in total, I eat 5 upon 4 parts of the pizza. If I repeat that again, now listen very carefully. I eat 1 whole pizza. And then I eat only 1 part of the other pizza, which is again cut into 4 parts. So in total, I eat 1 whole, 1 upon 4 of the pizza. If I write the whole separately, this format is called the mixed number. In the chapter of fractions, wherever we get the answer in improper fractions, we are required to change them into mixed numbers. Let's see how we are going to change our improper fraction into mixed numbers. Divide the numerator by the denominator. That means the top number will be inside the division box and the denominator or the bottom number will be outside. Let's use the same example, 5 upon 4. Let's make a division sum. 5 goes inside and 4 remains outside. 4 times 1 will give you 4. Subtract it and we get a remainder of 1. So after division, let's follow this rule. Our quotient or the answer on top becomes the whole number. Our divisor, that is the denominator, it stays as the denominator. And the remainder, which we get down over here, will be turned into the numerator. So we arrange all of these into our mixed number format and we get the same answer, 1 whole, 1 upon 4. I am attaching a video in the next slide. Please be very careful about that. We are going to solve more examples over there. Now we are going to convert our mixed numbers back into improper fractions. Please watch the video very closely. Many examples are discussed over here and it's a very good video for recap. Another very important concept from this chapter. Denominators same are used to compare the fractions and then arrange them in ascending or descending orders. We make the denominators same of 2 or more fractions to solve our addition and subtraction questions. How do we make the denominators same? There are 2 methods of doing this. We can make them same by either cross multiplying them. You multiply one fraction by the denominator of the other fraction, and the second fraction by the denominator of the first fraction. Or we can find out the least common multiple of all the denominators in front of us. Comparing fractions. To compare two or more than two fractions, our first step will be to make the denominators same. Let's solve an example. Which fraction is bigger, 5 upon 8 or 4 upon 7? Because both my denominators are not same, I cannot compare these fractions like this. So my first step will be to make the denominators same. Over here, I will use the cross multiply method. So my first step will be to multiply the first fraction 5 upon 8 by the denominator of the second fraction, and the denominator here is 7. So 5 upon 8 will be multiplied by 7. 5 multiplied by 7 gives us the answer of 35, and 8 multiplied by 7 will give us the answer of 56. My second step will be to multiply the second fraction by the denominator of the first fraction. So 4 upon 7 will now be multiplied by 8. 4 multiplied by 8 and 7 multiplied by 8. My new fraction is 32 upon 56. Now notice my new fractions, both of them have the same denominator. Now once this denominator is same, all I have to do is to compare the numerator. And I can see 35 is greater than 32. That means 35 upon 56 is greater than 32 upon 56. But keep it in mind, the comparison needs to be made in terms of original fractions. So 5 upon 8 is greater than 4 upon 7. Please watch the following video very carefully for more examples. In grade 4, you have studied the topic of LCM and HCF in great detail. You have solved many questions, and you know that LCM is another way to make the denominators same in the chapter of fractions. Let's look at this video and see how the LCM is used to make the denominators same. Once the denominators are same, you know that we can use it for either comparing fractions or to solve our operations. All the best for your worksheet. If you have any problem, please note it down and we will solve it in our Zoom class. Thank you.